Okay, for Chapter 9 Technology, we are going to start using our graphing calculator to find the confidence interval for the difference between two means. That's using the z-test when you're doing that. And so that'll be the standard normal. And there's two different ways you can do this. You can either have the data or you can have the statistics. So the first one there is one where we have the data. It says a researcher hypothesized that the average number of sports that colleges offer for males is greater than the average number of sports that colleges offer for females. A random sample of the number of sports offered by colleges for males and females is shown at the alpha level of 10%. Is there enough evidence to support the claim, assuming that the standard deviation for both 1 and 2 is 3.3? So first thing you need to do is list that data into list 1 and list 2. And you have 50 values for both of them, and so that's going to take you a while to enter in. So go ahead and pause the video. I'm going to enter those in list 1 and list 2, and then in the meantime you should be entering those in also. To remind you, in order to do that, you are going to hit the list button on your calculator. So you are going to hit the stat button in order to get the list in there. And then you're going to hit number 1 for edit. And then type in all your values in list 1 and list 2. Again, if you need to clear your list, you go up to the top, hit clear. That will clear the list. But otherwise, type in your values for list 1 and list 2. I've already got them in there. So if you need to, pause the video. And then once you're ready, turn it back on. We will continue with the directions on how to do your confidence interval. So once you have your lists in list 1 and list 2, you are then again going to hit the stat button. And then you're going to cursor over to the word tests. And for the test we are going to do, it's number 9, the 2 sample interval. You can see it way down on the bottom. You could cursor down to that. All right, so we're going to do number 9, which is the 2 sample Z interval. So I'm going to just enter on that, or you can just press number 9 to get down there. And then you have the option. You can either enter in the data, which we did, or you can do the stats. So this first one, we're going to do the data. And so when I entered in my values, the standard deviation for both 1 and 2 from our word problem says we wanted 3.3. So 3.3 for both of those. List 1 is list 1, list 2 is list 2. Again, if you don't have those in there, which is the default, you could hit second function and number 1 to get list 1, or second function number 2 to get list 2, but they should be there. Frequency for both of them should be 1, and then your confidence level, we were doing 90% confidence level because alpha was 10%. So at the 90% confidence level, we are then just going to get all those info in there. Once you get down to calculate, you are going to enter, and it's going to give you the confidence interval. And so you can see for your confidence interval, you are going to have negative 0.4656 and then 1.7056. That's your confidence interval. Now, the question on there wants to know, does the confidence interval contain 0? In this case, 0 is between a negative number and a positive number, which is what we have. And the reason that question is asked is if 0 is in your confidence interval, you do not want to reject the null. And so it can help you when you're doing your hypothesis testing later on. My hypothesis or my claim was, do the men have more than the women, more sports than the women? The null then would be that the men would be less than or equal to the women. Well, in this case, 0 is in our interval, so that means we are going to reject the claim that the men have more sports than the women. But it's another way when you're doing your hypothesis testing to see if your claim is true or not. If 0 is in that interval, then you don't reject the null, which means you'd accept whatever the null claim is, which is the one that has the equal to in it. Just to mention, this list of numbers, because it's kind of long, is also going to be used for a hypothesis testing one with the z-values. So you may want to skip ahead to about page 10 to where you have the hypothesis testing with the same table and do that one, so you don't have to go back and retype all those numbers in when you get to that problem. So the next one is one that you are going to do. My arm's not long enough, but it says try one from Alex. Again, it's going to have the data on there. It says past records suggest the mean annual income of teachers in the state of Florida is greater than or equal to the mean annual income of teachers in Washington. In a current study of a random sample of 15 teachers from Florida and an independent random sample of 15 teachers from Washington, they have been asked to report their mean annual income. So you're going to go ahead and enter in the Florida data for list 1, the Washington data in for list 2. Notice on this one, the population standard deviation for Florida and Washington are estimated at 6,300 for your standard deviation 1 and 6,200 for your standard deviation 2. Level of significance is going to be 0.1, so you're going to use your 90% confidence interval, and then go ahead and see if you think, or if it contains 0 or not. If it contains 0, you're not going to reject the null. In this case, the null is going to be what your claim is, because the claim included greater than or equal to. So your null claim would be that Florida is greater than or equal to the mean. So go ahead and try to do that one on your own. Okay, the next one we are doing the confidence interval for the difference between two means, doing that z distribution again. So the standard normal. On Alex, they will give you some that have tables and some that has the statistics, and so just depending on what you have for information, you're still going to do the same test. You're going to do the 2 sample z interval test, but sometimes you have to put your data in. Sometimes they just give you the statistics, and the statistics obviously is a little easier to put in. So the next one says, a study of 2 random samples of 35 people each found that the average amount of time in those age groups of 26 to 35 years spent per week on leisure activities was 39.6 hours, and those in the age group of 46 to 55 spent 35.4 hours. Assume that the population standard deviation for those in the first age group found by previous studies is 6.3 hours, and the population standard deviation of those in the second group found by a previous study was 5.8 hours. At alpha being 0.05, can it be concluded there is a significant difference in the average times each group spends on leisure activities? So if we're trying to conclude if there's a difference, we want to say that mean 1 does not equal mean 2, or mean 1 equals mean 2. My null should actually be the one with the equal, so my null hypothesis would be, does mean 1 equal mean 2, and my alternative hypothesis, does mean 1 not equal mean 2. So again, in order to calculate this test, we are just going to go ahead and hit the stat button. So we're going to find stat. And then we're going to go up to the top, cursor over to the word tests. And again, we're going to do the number 9 test. I'm going to just hit the number 9, and it's going to jump right to your thing instead of going down and highlighting and enter. And this time we're going to enter in the stats. So if I'm entering the stats in here, the standard deviation for the first group was 6.3 hours. So 6.3. My standard deviation for my second group was 5.8 hours. So 5.8. Whoops, I got a cursor to stat and I didn't do that. Let me go back up to the top. I don't want to do data. I want to do stats. So I got to go over to stats and enter on stats. There we go. So again, back to that. My standard deviation for the first group was 6.3 hours. My second one, 5.8 hours. My mean on this one was the 39.6 hours for the 26 to 35 year olds. So 39.6. Number samples of 39-year-olds are 26 to 35 year olds was 35 people. So N is going to be 35. My next group, the mean hours was 35.4 hours. So 35.4 hours. the number of people in that second group was 35 people for each group. So that was also 35. So that N is also 35. My confidence level, I'm doing the 0.05, which means I'm at a 95% confidence interval. So 0.95 there. So make sure you have stats highlighted. Standard deviation 1 is 6.3. Standard deviation 2 is 5.8. The mean of the first group was 39.6. The number of people in the first group was 35. The mean of the second group was 35.4. The number of people in the second group was 35. And my confidence level is 0.95. And now we can calculate that. So when we calculate that, we can see that our interval is 1.363 to 7.037. 1.363 to 7.037. In this case, does our interval contain 0? Well, since both the values in our interval are positive, 0 would not be in that interval. And so if 0 is not in the interval, you are going to reject the null, which means in this case you're going to reject that they are equal. And so you would have to accept the claim that they are not equal to each other. And so is there a significant difference? We are going to say yes, there is a significant difference. They're not going to be equal to each other. Now you're going to try one from Alex. It says, according to historical data, the life expectancy in the United Kingdom is less than the life expectancy in the United States. A new study has been made to see whether this has changed. Records of 275 individuals from the United Kingdom who died recently are selected at random. So 275 would be your N1 value. The 275 individuals lived a mean of 78 years, so that would be your mean 1, with a standard deviation of 5.8 years, which is what you're going to put in first as your standard deviation 1. Records of 240 individuals from the United States who died recently are selected at random and independently. The 240 then is your N2. These individuals lived a mean of 76.8 years, which is your mean 2, with a standard deviation of 6.3 years, which is your standard deviation 2. Assume the population standard deviations of lifetimes in these two countries can be estimated by the sample standard deviations, as the samples used were quite large. Construct a 90% confidence interval for mean 1 and mean 2, the difference between the life expectancy of mean 1 in the United Kingdom and the life expectancy of mean 2 in the United States. Then complete your table below. So again, on this one, you are going to go ahead and do your stat button. I'm going to grab my calculator here. And so you're going to press stat. Cursor over to the word tests. Whoops, helps if my screen is on. Press stat. Cursor over to tests. And you're going to do test number 9, which is the 2 sample interval. Make sure you have stats highlighted. Enter in the stats from the word problem. And then check to see if 0 is in that interval. If 0 is in the interval, you should reject the null. In this case, we were checking to see if United Kingdom is less than the life expectancy. So your null would be, is your mean 1 greater than or equal to mean 2? And your alternate hypothesis is mean 1 less than mean 2. So if it contains 0, do not reject the null, which means you would accept the null. If it does not contain 0, then you would accept the claim, which is the United Kingdom is less than the life expectancy in the United Kingdom is less than the life expectancy in the United States. So go ahead and try that one. So the next one here, we are again going to do the confidence interval between two means, but this time we're doing the t-distribution. When you do not know the standard deviations, then you have to use the t-distribution. And so it says, is there a significant difference at the alpha level of 0.10 in the mean heights and feet of waterfalls in Europe and the ones in Asia? So when they ask if there's a difference, you're wanting to know, is mean 1 not equal to mean 2? So again, we have to first enter our data in our list. I've already put them in there, but then to remind you again, to put your data in the list, you are going to press the Stat button. You are going to hit number 1 to edit the list, and then go ahead and type your data in. Again, if you need to clear the list, highlight, cursor the top where it says L1, hit clear and enter, and then L2, clear and enter. Again, I've already put the data in, but if you need to pause the video so you can get your data entered in, go ahead and do so. Okay, so once you have your data entered in on your list, again, you are going to go ahead and hit the Stat button, and you're going to go over to Tests. This time our test is test 0. You can't see it right now. I'm going to cursor down, but you could press 0 and hop down to the test. But notice 0 is your 2-sample t-interval test. Your 2-sample t-interval test, again, you have 2 options when I enter on that. You can either have the data or you can have the stats. So if you have the data, you can type it into list 1 and list 2. If you have the stats, we will put the stats in there. So first one here, we have the data. We've put it in list 1 and list 2. The frequencies are just both going to be 1. And my confidence interval on this one was at the 10% alpha level, so the 90% confidence level. And then I ask you if you want it to be pooled or not. So on Alex, I have found that you do want to have pooled highlighted. So you want to have pooled being yes, that they are pooled. I noticed that when I did my calculations and I compared them when I was trying problems on Alex, that we needed to have yes for that one. So when I go ahead and hit calculate, I'm going to enter there. My confidence level there, negative 314.9 to 400.71. So again, when I look at that confidence interval, and I ask the question, does the confidence interval contain 0? Yes, because the first one's negative and the second one's positive. 0 would be between negative 314.9 and positive 400.71. And if that interval level does contain 0, you are not going to reject the null. So in this case, the null would be that the two things are equal. The alternative claim would be that they're not equal. So in this case, we are not going to reject the null, so we are going to say they're equal. So can we say there's a difference? No, we cannot say there's a significant difference between those values. And that would be our conclusion. Again, once you get into the hypothesis testing, sometimes go ahead and check the confidence interval and double check what your claim is to see if you've come up with the same solution by using the p-test or by using the test statistic. And if you haven't done a bunch of those, you'll know what I mean once you get to those. Alrighty. Now the next ones here, we are still going to do the confidence interval for the difference between two means using the statistics. In this case, most of them that I did on Alex, in fact all of them that I hit on Alex, only did the ones with the statistics. And so that's why I didn't do one from Alex where you had to type in the data, but there may be some with the data and I maybe just didn't get to those ones. And so I'm going to have you do one together, and then I'll have you do one that I found on Alex on your own and see if you can get the same results either way. So in this case, the first one says, a study was done to see if there's a difference between the number of sick days men take and the number of sick days women take. A random sample of 9, which would be our N1 men, found that the mean number of sick days was taken was 5.5 sick days for the men. The standard deviation of the sample was 1.23 sick days. So notice this is the sample standard deviation, not the population standard deviation. When they give you the population standard deviation, you use the z-test. When they give you the sample standard deviation, you use the t-test. A random sample of 7 women were found that the mean was 4.3 days and the standard deviation was 1.196 sick days. So at an alpha level of 0.05, can it be concluded that there is a difference in their mean? Again, they're asking, is there a difference? which means your null hypothesis would be that they're equal. Your alternative hypothesis, they're not equal. That is what the claim is. Is there a difference? So again, I am going to use my stat button on my calculator. I got to turn it back on. Hit the word stat. When you hit the word stat, it should come up with your menu. We want to do the tests. And again, we're going to do the t-test, which is 0. I can hit 0 and go directly to it, or you can cursor down to 0. You should see that it says the 2 sample t interval. This time, instead of doing data, we're going to do the stats. And so I got to enter on the word stats, and then I got to put my information in. So mean 1 was 5.5 sick days for the men. 5.5. Standard deviation 1 was 1.23 days. 1.23. The number of people sampled of the men was 9. Hey, I conveniently already have 9 in there. So now I'm going to go down to mean 2. Mean 2 for the women, the mean was 4.3 days. 4.3. Standard deviation from the sample of women was 1.19. 1.19. And the number of women that they sampled was 7. So I got to change that one to 7. And my confidence level, I am going at a 0.05. So I'm going to have a 95% confidence level. 0.95. So I've got my information in there. Mean 1 was 5.5. Sample standard deviation 1.23. Number for 1 was 9. For 2s, the mean was 4.3. Sample standard deviation was 1.19. And 7 people sampled for the women. Confidence level 95%. And yes, we want it pooled. Make sure yes is highlighted. We are then going to hit calculate. So I'm going to enter on calculate. And you can see that my confidence interval is from negative 0.1111 to positive 2.5111. So, looking at that, is 0 between those two numbers? Well, since one's negative and one's positive, yes, 0 is in there, which means if the confidence interval contains 0, you are going to do not reject the null. So if you're not rejecting the null, that means you're accepting the null and you're saying that the two things are equal. The question asks, is there a difference? You would have to say no, there is not a difference. So the one from Alex that you're going to go ahead and do says, right there, one from Alex, the managers of an industrial plant want to determine which of two types of fuel, gas, or electric is more cost efficient, measured in cost per unit of energy. Independent random samples were taken of plants using electricity and plants using gas. These samples consisted of 12 plants using electricity, which had a mean cost of $52.90 and standard deviation of $8.51. So I've marked those for you. And 13 plants using gas, which had a mean of $56.80 and a standard deviation of $8.41. Assume the populations of cost per unit are normally distributed for each type of fuel and assume the variances of these populations are equal. Construct a 90% confidence interval for the difference between mean 1 and mean 2, using the electricity being mean 1 and the mean cost for plants using gas for mean 2. So you are going to go ahead and compute your confidence interval. Again, in order to do that, you are going to press the stat button. Once you hit your stat button, you're going to go cursor over to the word tests, and you are doing the t-test, so you can either cursor down to 0 or just press the 0. And if you cursor down to 0, you have to enter and do your 2 sample interval test. Make sure stats is highlighted. Go ahead and enter your stats and see what you come up with for your confidence interval. All right, the next kind of confidence interval we're going to do is the difference between two proportions. It says in the nursing home study mentioned in the chapter opening statistics today, researchers found that 12 out of 34 randomly selected small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At an alpha level of 0.05, test the claim that there is no difference in the proportion of small and large nursing homes with a resident vaccination rate of less than 80%. So on this one, our claim is that there is no difference, so that would be the one with the equal, the null hypothesis. Okay, so we are going to go ahead and press the stat button, cursor over to test, scroll down to B for 2 proportion Z interval, and then type in our appropriate values. So I hit stat, went over to tests, and I'm going to cursor down to B. So 0, then A, then B. You want the 2 proportion Z interval test. 2 proportion Z interval. And then I'm going to enter on that. So in this case, you're basically putting in your proportions. In the first one, 12 out of 34. So I'm going to put 12 for X1, and N1 would be 34. On the second one, you had 17 out of 24. So I'm going to put 17 out of 24. And then you're going to put in your confidence level. And your confidence level on this one was 95%. So I've already got that in there. And so when you have your proportion, X1 is how many out of the total number. X2, how many out of the total. And again, I'm going to hit calculate on that. So I'm going to enter. And we can see that our confidence interval is from negative 0.598 to negative 0.1128. So in this case, is 0 in between 2 negative numbers? No, 0 is not in there. So in this case, that we are going to, since the confidence interval does not contain 0, we have to, all right, so the confidence interval was negative 0.598 to negative 0.1128. So does the confidence interval contain 0? Well, since both our numbers are negative, no, it does not contain 0. So if the confidence interval contains 0, you do not reject the null. So in this case, since it does not contain 0, we are going to reject the null. Since the null was our claim that P1 equaled P2, we have to reject the claim that there is no difference. We have found that the alternative claim is true, that P1 does not equal P2, that there is a difference. So if the confidence interval does not contain 0, you are going to reject whatever the null claim is. And the null is what our claim is, that there was no difference. So you are going to go ahead and do the next one, which is one off of Alex. It says a random sample of 225 bolts from machine A contained 18 defective bolts, while an independently chosen random sample of 350 bolts from machine B contained 31 defective bolts. Let P1 be the proportion of the population from machine A that are defective, and P2 be the proportion of the population of all bolts from machine B that are defective. At your 90% confidence interval, then complete your table. Carry your computations to at least 3 decimal places. And so, again, go ahead, put your information in. Decide if the confidence interval contains 0 or not. And just a note on when you're doing these confidence interval ones, I have found that when I use the formula, that sometimes I was slightly off from the problems due to rounding issues. However, when I did the problems on Alex, I couldn't find any that were counted wrong, so I don't know if it was just a coincidence or what, but if they were off, it was off by just a thousandth of a percent. And so if you're doing them with your calculator and they count it wrong, let me know, because all the ones I did were counted right when I did them with the calculator. The next kind you have is the confidence interval for the ratio of population variances. We don't have a technology activity for this because you can't do it on your graphing calculator. And so those ones you will have to use the formula in order to do.